In this video, we will look at arithmetic sequences. Now, an arithmetic sequence is a sequence of numbers where the difference between any two terms is always constant. This difference is called the common difference. The terms in an arithmetic sequence are connected by a rule, and the general term gives us that rule. For example, if we have a sequence 3, 5, 7, 9 and so on, we call the first term, term 1, we also call that A. In this case it's 3. We can see clearly that the difference between each of the terms here is 2. And then we have a formula to find the general term. Tn is A plus n minus 1 times d. So that's an important formula. In this case, Tn is equal to A, which is 3, plus n minus 1 times d, which is 2. Tn is equal to 3 plus 2n minus 2. In other words, Tn is equal to 2n plus 1. So that's the general term for finding any of the terms in that sequence. And we can see very quickly that 2 times 1 plus 1 is 3, 2 times 2 plus 1 is 5, and so on. This piece here is a very useful summary, particularly noting that the difference between any two terms in an arithmetic sequence is d, the common difference. We look here at increasing and decreasing sequences. If a term is bigger than its previous term, then of course the sequence is increasing. And if a term is smaller than its previous term, then the sequence is decreasing. We'll do question 1, part 1 here from the exercise. So we're told that we're asked to find Tn, the nth term, the general term, and then we're asked to use that to find T22. So we'll just take that. Looking at the first one, the sequence is 8, 13, 18, 23, and so on. And we can see quite quickly that the first term, A, is 8, and the common difference, that's the amount between each term, well, we can see, of course, that that is 5. Using those pieces of information, we just have the formula for the general term. Tn is equal to A plus n minus 1 times d. And filling in the values, it's 8 plus n minus 1 times 5. So that's 8 plus 5n minus 5. Tidying up, we get that Tn is equal to 5n plus 3. Now a quick check, we can just see, if we look at the first term, 5 times 1 plus 3 would be 8. 5 times 2 plus 3 would be 13. 5 times 3 plus 3 is 18, and so on. In this question 3, part 3, we're asked to find how many terms is in the sequence. So in other words, in part 3, if we start at minus 3 over 2 and we go up to 14, how many terms will it be till we get to 14? As always, we start with working out A and D. So in this case, A is the first term, minus 3 over 2, and D is the difference between any two terms. Might be easiest to look at from minus a half to 0. That means you go up a half. So the difference is a half. And then we can easily work out the general term. So it's Tn is equal to A plus n minus 1 times d, which is minus 3 over 2 plus n minus 1 times d, which is a half. So we've minus 3 over 2 plus a half n minus a half, and that gives us a half n minus 2, because minus 1.5 minus a half is minus 2. We now have a formula for the general term, and we know that some term, but we can just call it Tn again, some term is 14, because that's the term that we're asked about. Which one? How many is it till we get to 14? Well, that means, of course, that a half n minus 2 is equal to 14. That's the important part, making the connection between the formula and the term we want. And then it's just simple algebra. A half n, adding 2 to each side, is 16. If a half n is 16, then n is 32. So that means that term 32 is equal to 14. In this question, we're given an arithmetic sequence. We're told the 13th term is 27. The 7th term is 3 times the second term. And then you're asked to find an expression in terms of n for t13, for t7, and for t2. So those 3 things first. Hence, in other words, use those answers to work out the values of a and d, and then write down the first 6 terms of the sequence. So a few things going on here. First, we want to find the expression for t13. We know that tn is a plus n minus 1 times d. That means that t13 is going to be a plus 13 minus 1 times d, because n here is 13, and therefore we can just say that t13 is a plus 12d. So that's the first piece done. Now we have to find an expression for t7. Again, we use the formula tn is a plus n minus 1 times d. So when it's t7, in other words, n is equal to 7, so a plus 7 minus 1 times d, and therefore t7 is equal to a plus 6d. Finally, we're asked to find an expression for t2 before we move on. So tn is a plus n minus 1 times d. This time n is equal to 2, so t2 is a plus 2 minus 1 times d, and therefore t2 is equal to a plus 2 minus 1 is 1, so 1 times d, or a plus d. Continuing on with this question, we want to find now the values of a and d. We found a moment ago that t13 is a plus 12d, and we also know that t13 is equal to 27. So this means that a plus 12d is equal to 27. We found expressions for t2 and t7 already, and we also know that t7 is equal to 3 times t2. So this means that a plus 6d, because that's the expression we found for t7, is equal to 3 times a plus d. Just tidying that up, we know that a plus 6d is equal to 3a plus 3d. Gathering them all together on one side, we would have minus 2a plus 3d equals 0. We now have 2 equations and 2 unknowns, so we solve them simultaneously. There's our first equation and our second equation. So if we take our first equation and multiply it by 2, we'll get 2a plus 24d equals 54. And we just leave our second equation as it is, minus 2a plus 3d equals 0. And we just add those together. 2a minus 2a is 0. And then 24d plus 3d is 27d. And 54 plus 0 is 54. Divide both sides by 27. And that gives us then that d is equal to 2. So we now have d, and of course we can just substitute that back into our first equation. A plus 12d is equal to 27. Just using this equation up here. And we know that d is 2. So that means that a plus 12 times 2 is equal to 27. A plus 24 is equal to 27. Gives us, of course, that a is equal to 3. And we now know our a value is 3, and our D value is 2. So that was the next part, find the values of A and D. All we have to do now is write down the first 6 terms of the sequence. In order to do the final part of this, we want to find this first 6 terms of the sequence. We know that A is 3, that's the first term, and D is 2. So very easy then to say that the first term is 3. The common difference is 2. That means we add on 2 each time. So we just get 3, 5, 7, 9, 11, and 13. And they are the first 6 terms of the sequence. In this final question here, we're given that the nth term of the sequence here is 4n minus 2, and we're asked to show that the sequence is arithmetic. Now, some people would be tempted to just find some terms and show that the difference between them is constant. But of course, we have to show that it's true for all. So we must remember that for a sequence to be arithmetic, that the difference between any term and its previous term must be constant. That's what we mean by an arithmetic sequence. And we're going to try and work that out. Tn is 4n minus 2. Tn minus 1, so the previous term would be 4 times n minus 1 minus 2. In other words, 4n minus 4 minus 2, which is 4n minus 6. Tn is 4n minus 2. Tn minus 1 is 4n minus 6. And we get the difference between them. We look at Tn minus Tn minus 1, and we'll work that out. Tn is 4n minus 2, and we're going to subtract the previous term, Tn minus 1, which is 4n minus 6, and we work that out. 4n minus 2 minus 4n plus 6 gives us 4n minus 4n is 0, and minus 2 plus 6 gives us 4. Now it's very important that we say Tn minus Tn minus 1 is equal to a constant. It's not the fact that it's 4, it's the fact that it's a constant, and therefore Tn is an arithmetic sequence. So we're looking back here and reminding ourselves that here is constant. There's no n involved in it. So you could always write in constant there beside it. You should now pause the video and do the marked questions.